This little animation here shows how a relay functions. So there is a coil of wire which, when electricity flows through it, becomes magnetic. So this low voltage, low power circuit can be used to operate a high powered circuit over here. And the magnetism created by this electromagnet can open and close the contact, this blue contact that you're seeing here. Okay, so in the task that we were set, we were given a single pole double throw relay and a motor, and we were asked to connect it up so that it would switch on and off. So you would need to draw in some wires to a separate power supply, and that would go round to the motor. And then finally it would go back to either one of these two contacts. If I put it back to this one, for example, then that would be normally open. So when the electricity flows through the coil of wire in this green bit of the relay here, then it becomes an electromagnet, and it would close this contact, and therefore completing the circuit, allowing the current to flow. The reason I've got the transistor and the relay here, the transistor and the diode here, are because they would be quite commonly put here to switch the relay on. So for example, putting the diode in parallel with the relay would protect the transistor from the back EMF created by the relay switching on and off. So there's how you would operate. You would use this transistor to switch on the relay, which can then power this bit over here. So onto the double pole double throw relay, and we would be doing something like this. So again, we've got the power supply, which needs to be connected to those two contacts there. Now, if I wanted the motor to travel in one direction, then that would need to be connected to there. And if you can follow this round with me, then that connection there would need to go to that side of the motor. And as you can see there, I've now got a complete circuit. So in the position shown, these contacts, the current would flow through and turning the motor in one direction. If the relay was energized the other way and the contact moved back to the position on the left, then what I want to happen now is I want the current to flow through the motor in the opposite direction. So I would wire it to the other side. I'll just change the color of that so it's obvious, and I'll do the same with this one. So this needs to go to this side of the motor so that the current can flow through the motor in the other direction. Again, you weren't asked for this, but you could use the transistor and the diode, wire them up on this side to complete this, to switch the relay on and off.